Okay, good morning to everyone. We wait just 1 minute to allow participants to connect. The number of participants is increasing, so just a few minutes before starting. Okay, I think that we can start. Good morning or good afternoon to everyone. I am Monia Santini, researcher at the Foundation Euro-Mediterranean Center on Climate Change, CMCC, and I welcome you to this webinar held today by Marco Mancini, a colleague from the Division on Advanced Scientific Computing. And Marco leads the research unit on data platforms and services, which aim at integrating information communication technologies for the development, the deployment of platform and tools to support CMCC research in different sectors. Today, Marco will tell us something more about the CMCC Data Delivery System, DDS, which is operational since December 2020 for publishing and disseminating a scientific dataset produced by CMCC, and then evolved up to the current version. Whose functionalities, architecture, and components will be described during this webinar, including Geocube, which is a Python library for the analysis and visualization of climate and related impact data indicators, to conclude with some information about the future expected development of the DDS. But before starting, I want to say something about the CMCC Foundation, a research center to study and analyze the climate and climate-connected topics and developing models on the climate system and on its interaction with the ecosystem and the human system. The main goal of CMCC is producing useful results for the society and supporting both adaptation and mitigation policies based on scientific knowledge, in turn simulating the protection of the environment and the sustainable growth. And CMCC was first established as a consortium, and then it became a foundation in 2015, and its members are Italian universities, research centers, and international organizations, which complement the CMCC expertise in different directions. This is also why CMCC is organized as a network of thematic centers, and with offices distributed across Italy, from Lecce, where we have our headquarters, to Caserta, Viterbo, Sassari, Bologna, Venezia, and Milano. And these thematic centers convert into 11 research divisions that deal with the different aspects that surround climate science, from atmosphere to ocean processes, to their feedbacks with terrestrial and marine ecosystem, both from a biophysical, biogeochemical point of view, up to assessing the risk and formulating possible solutions for the environment, the economy, and the society, all in the context of the challenges toward climate resilience and carbon neutrality. These organizations allow to address in an interdisciplinary way the different issues and to consider the relationship between the natural world and the human environments. Another peculiarity of CMCC is the Supercomputing Center, operational since 2008, and also computing and storage facilities were upgraded last year, leading to the new Supercomputing Center that is hosted in the new building of CMCC headquarters in Lecce. Last but not least, CMCC works actively to raise awareness outside the organization through activities that range from scientific dissemination through publication to the communication to a wide and heterogeneous audience, thanks to events, articles, and other engagement activities, up to not neglecting the training of students to stimulate their interest in the field of climate change through PhD programs and also dedicated schools. Now, some brief information about the webinar. The audio and video of the participant are switched off by default, but you can participate in the Q&A session using the appropriate chat or raising your hands in case I will give you the floor, even if I prefer that you write your question in order to optimize time and try to condense to integrate similar questions. At the end, Marco will answer to your question, but also in case time is not available, he will also answer by email after the end of the webinar. And for those that are not able to attend today, I want to remind that the webinar is recorded and it will be circulated soon through the CMCC social network, including the YouTube channel. So now I can give the floor to Marco, who can share his screen and enjoy the webinar.
Okay, thanks, Monia. And let me. Okay. Do you see the screen?
Yes.
Is okay? Okay. So I can. Okay. Thanks. Thanks to everyone that is participating. So as Monia said, today I will going to present the CMCC Data Delivery System that has been deployed since December 2020 at CMCC, and I will give an overview of the service and especially what we have recently developed and also what we'll develop in the future. And I will introduce also a framework that we are developing together with the data delivery system, that is the backend of the system itself. Okay, so let me start first to give you a brief overview of the system. You can see on the left a video that is showing the web portal and how you can browse the datasets that are available. And then now you can now choose your dataset and your products and build your queries by selecting variables, temporal, for example, subsetting by time or subsetting by spatial coverage and so on. And then you can use the web portal to look at your request and download the data that has been generated by using the web portal when you do your queries through the interface. So what are the features of the DDS? So first of all, this is we have developed this in order to provide a unique point in order to publish and all the data that are produced by CMCC. We also use the data delivery system in order to provide also a point for data that are used by CMCC Research and CMCC Division. So we have, as you can see, a catalog of dataset that is easy to use. And one of the most important points is that we have developed an API that allow the users to easily do the queries and download the data that are available on the service. And this API is used or by the web portal or by a Python-based client that you can use, for example, for data downloading. The DDS has been used in different contexts. For example, we are using in some of the projects, like, for example, in order to prepare the training and validation dataset for some machine learning algorithms, also to deliver some products that have been developed, for example, in the Silvanus project. We have recently delivered also the WPS OGC interface that I will talk about this later. And this has been integrated in the CNS project, for example, in the Climate for Impact portal that can be used, for example, for processing SGF files produced by CMCC. Also, we use the DDS to publish datasets, scientific datasets that are, for example, published in some journals like Scientific Data or MDPI Data and so on. Like, for example, the very high resolution, the scaled ERA5 and projection, and also the SPACE dataset that has been recently added to the CMCC Data Delivery System, and then we can also disseminate other project results. Recently, we have upgraded the system, so since mid-March 2023. So we also have collected some statistics that are actually related to what we have deployed recently. So now the number of registered users is about 360 users, and we have also more than 100 active users. So active users are the users that not only registered, but have used at least once the API in order to do some requests and to download some data. At the moment, we have 22 CMCC datasets that has been published here, and we manage around 150 terabytes of data. Usually, the average time to execute a request is pretty fast, but this depends on the type of request that you do, in the sense that if you cover a large range of time or spatial, it can take more time. But on average, we have found out that is pretty fast in delivering the request. Clearly, we are talking about the time to execute the request, then there is a time in order to download the data. Okay, now I would like to introduce to you the new architecture that has been deployed in the mid-March, in order to give you an overview of what are the different components that we have integrated, and also I will talk later about Geocube, that is this framework that we have developed together with the DDS. Okay, so let me go. I don't know why. Sorry, 1 second. Okay. Okay, so first of all, as Monia said already in the introduction, CMCC is a supercomputing center. So we have developed this system integrated within the supercomputing center facilities. So there is a dedicated storage, a tier 2 storage, where there are most of the files related to the dataset that are produced by CMCC division that would like to be published, for example, through the DDS. So in the supercomputing center, we have, beside the HPC facility, we have also now a cluster that has been with Kubernetes that has been dedicated to deploy the data delivery system. The system has one main component that we call data store, where we have two main components within it. So one is about the dataset catalog, and this is allow us to define this abstraction like dataset or products within the dataset. So we, in order to define this, we have different drivers according to the type of file that we have to deal with. Most of the files are usually netcdf, in format netcdf, but we deal also with the GeoTIFF or GRIB files. So these drivers allow us to load, to read the metadata, for example, the header of the netcdf, and to put this within some in-memory data structure by using, and we use intake as the library in order to do this loading within in-memory data structure. Clearly, we cannot, every time for each request, we cannot open just the header of the files, because we can have dataset with thousands of files or hundreds of thousands of files, like SNP6. So in this case, we had to implement a sort of caching of the metadata. And this allows us to do request faster, because we are not going to read every time the header of the files. We are improving this by also introducing a metadata DB. This is in development, it's still not in production, but will be in production soon. And this will allow us to be even faster, especially in dealing with for example, the web portal interaction, and also to do queries, especially on the metadata side. So this is the part of the dataset catalog. Then the other part is related to the query engine. That is the main component that allows us to, for example, to subset a product by time or by latitude, longitude, by area, or by locations. And so do different operations on the dataset that are related to the query by the end user. So here, in order to deal with we have limited resources, so we have implemented the system in order to queue the different requests, and we have used RabbitMQ. So every time a request comes, it will be put in a queue, and then we will have different executor. So if some executor is available, the broker, RabbitMQ, will dispatch one of these requests to one of the executor. The executor uses Dask for parallel processing and Geocube. This is the framework that we have developed that I will talk a bit later. So they will use this in order to execute the query and then put the result in a storage, temporary storage that we use as a cache for the result. So for example, they create an SDF that corresponds to the query of the user. In order to keep the state and to understand in which state is the request, we have a dedicated DB for the request, where we can have the state, for example, pending, queued, or running, is done, or failed, and so on. Okay, so this allows us to the different components of the DDS to understand in which status is the request actually. So these are the two main components. There is another component within the data store that is related to the authentication and authorization. So we have defined in a DB what are the users, and what are their roles, because we have implemented also some access control lists. For example, we would like to have some datasets that are public, so everyone that registers to the DDS can access. This is related maybe to the result that CMCC would like to disseminate or publish. But we can have also internal datasets that are just used internally at CMCC or for some project and so on. So we have defined this kind of access control list that allow us to manage and to control which dataset to publish and which dataset instead to just use by some groups or by some internal users. This has been integrated with the identity management system of the supercomputing center that is based on Keycloak. So there is a sort of, let's say, sync between these two systems. So every time the user registers by using Keycloak, we update our in the DB of the data store. So this has been done through an integration. So in order to deal with the data store, we have defined an API, a REST API that allow, the users of the REST API to do queries about the dataset or to do queries about some products and also to execute queries. And through this REST API, we have defined then what are called the user interfaces. So the different ways in order for an end user to interact with the DDS. In particular, as I already said, we have a web portal that allows the user to use a web interface to interact with the DDS. We have developed also a Python client that you can use by using a script. This script is also available to the web interface. And then we have developed also some OGC interfaces, and that I will talk to you later, in particular the WPS OGC interface. Finally, the latest components are related to the monitoring of the system. So we have integrated the Prometheus that collect all the statistics of different components, and also Grafana to have different dashboards that allow us to monitoring and so to troubleshoot in case of issue we have in the system. So this is the overall architecture that we recently deployed for the DDS that allow us to manage better also issues that we had in the past for the system. Okay, this is the REST API that is available from the DDS, and this is what allow us to interact with the different components of the DDS. So, for example, you have a part related to the dataset that can be queried, for example, to get metadata about one particular dataset or one particular product that is defined within a dataset. And we have some endpoints that allow us to execute queries. So we have an execute endpoint, and I will talk also about this workflow endpoint that we recently added. And this was due to the fact that we wanted to deliver this WPS OGC interface. And then we have a part that is related to understand, for example, what is the status of the request, the size, and in case the request is done, how to download, so the URL for downloading the request, the result of the request. So this is the REST API. So the two main endpoints are the execute endpoint. So this is how the endpoint can be used. In particular, we use JSON in order to send to the endpoint the data that is needed for executing the request. And this is in the Python web client in the Python client is equivalent to the dict that you have to pass. So in particular, you have to specify the dataset ID, the product ID. You can specify some variables of that dataset of that product. And then, as I said, you can do subset by time. You can specify as a combo or as a range. And also, for example, the area or location. So the area as a bounding box. You can also specify the format. In this case, netcdf. We also recently added other formats, but at the moment are not available in the public dataset, but this will be added in some future release. And this is the execute endpoint. What we recently added in the DDS is the workflow endpoint. So in this case, it's also a JSON that represents different tasks. So you can do, for example, a subset operation, then you want to do a resample operation. For example, you have an hourly data set, you would like to have a daily data set or a yearly, and so on. And we have added, at the moment, resample, so average by time. This few operator at the moment, we will add other in the future. And what we do is to use a network analysis library, NetworkX, that is a Python library. Then what will be is a graph, and then we order by topologically this graph, and then we execute by the executor, so the different operations. Okay. So, and this is the workflow endpoint. So instead of using just one operation, you can have, let's say, multiple operations, and then the result can be downloaded from the DDS. Okay. This is the DDS Python client. You can see on the left a demo on how you can use it and how you can do a retrieve from the DDS. So the main important thing here is that, first of all, clearly you have to install it in your Python environment. We have both, you can use both Conda or pip. You can see the instruction on the right of the slide. And then what you can do is to submit a request by using this retrieve. At the moment, in the when you install the DDS API, you can use only the execute endpoint, but we are going to release the new version where you can also use the workflow endpoint. As you can see on the left, you have to pass, in this case, the workflow, as I showed before. In this case, you will execute not only a subset, but you can use, for example, a resample on the data. Also in the video, it showed how we use the Geocube framework in order to plot the data that has been downloaded. So this is one way in order to interact with the DDS. The other way that we released recently is the WPS. This is based on Rook. That is a Python framework to build WPS. So we have modified it in order to be integrated within the DDS. So you can install the WPS Python client Rookie, and then you need to set the URL for the WPS. And then, as you can see here on the left, the video about how to use the WPS. And in particular, what you can do is to create a workflow that, in this case, for example, you can subset, you can average by time, and then you can average resample, and then you just call WF orchestrate, and then it will execute the workflow on the DDS. So in this case, what we have done is to create this OGC interface that uses the workflow endpoint for the DDS. Okay. Okay, so let me go. Now, so this is our, now I will introduce the Geocube framework that is that we have developed together with the DDS. That is the backend that allow us to do this operation and to do analysis. But this framework can be used also for visualization analysis outside of the DDS. So what we would like to do very soon, I hope after this summer, is to release the Geocube, and also the client, the DDS client, will have integrated this package, so you can, let's say, connect to the DDS and then, I don't know, do visualization and further analysis locally with the result coming from the DDS. So we started from some framework, and in particular from xarray, and also from some data model that are the Unidata common data model and the climate forecast data model, let's say, convention. So what we are trying to do is to build a data model that is a data model for geoscience in general, because what we have witnessed is that xarray is a very good package, but is very tight to the NetCDF data model. And this has some issue, for example, in providing some operation. So the idea here is to abstract more the data model in such a way that is simplified for the user to do some operation like, I don't know, a bounding box where latitude and longitude are not index for xarray, are not dimensional axis. For example, you have a rotated pole or you have a projection, and then latitude and longitude are not, let's say, dimension where you can do your selection. So the idea is to improve the user experience in order to do analysis. And so what we have done is starting from this data model and from the xarray API to build this framework on top of that. So one of the things that we have introduced that axis for us is as a semantic. So these are data, let's say, data structure within the framework. So you have axis, latitude, longitude, and so on. And then you can use them in order to do operations on the dataset, for example, that you. And we provide different operations of analysis and visualization for different type of geoscientific dataset. That could be gridded or could be points, time series, profiles. So we have added also this kind of abstraction within the framework. Okay, so the basic structure in Geocube is field. So field can be, as I said, can be different types of field. So a field is a variable defined over a domain. And this, for example, can be a grid, or could be a profile, for example, of a device, or could be just points, observation points, or a time series. And so we have a construct for the field. So we have a name and then a variable associated. The API, as you can see, is very similar to the API of xarray. So you have just to pass the data. We also, Geocube is units aware. So you can pass units. In particular, we use the Python package. And then the dimensional axis, these are the axes where your field is defined. And the axes, as I said, are objects in Geocube. So they are predefined somehow. So we have axes for longitude, latitude, and vertical, and so on. And you can also add, let's say you have a user-defined axis, for example, are discrete axes that are not geo-referenced axes. You can create this axis and by using a create method within the axis module. And as I said, the field is a variable defined over a domain. As I said, also in this case, domain can be different types, and a grid or profile, and so on. And in this case, what you have to provide are coordinates where the key is the axis. So you can see on the right, in this case, for example, for axis time, we have this data structure. And also, as you can see here, we deal also with the intervals. So for example, in this case, the time are defined as intervals. So this means, for example, the day from 1st of January 2020 to 2nd January. So that's the day. And this also allows us, for example, for some data set to have operation over intervals, not only over the instant of time. So for each of the axes, you can associate a data structure, and also, in case, also define what is the units associated to that value, for example. Okay. So this is the basic structure that we have, is field. And the latest part clearly is that we deal also, as I said, with different types of, let's say, coordinate system. For example, you can have a geodetic. So in this case, you have just latitude and longitude, or you can have a rotated pole, or some projection like Lambert and Mercator. So you have to define, in this case, the coordinate reference system. And this will be taken into account in the operations that you are going to perform on the field. So for example, so we provide different methods for the field in order to manipulate itself. There are some methods that we have kept just to have the same API as xarray, but there are some methods that are just for the framework Geocube that I will show you. We have some method because we can go from xarray to xarray, so from netcdf files, let's say, to this kind of data structure that we have defined. So you have a method from xarray to xarray. And then what we have redefined, for example, for field, is the get item. So you can use just the square brackets in order to select, for example, to subset your field by using some axis. In this case, you can see in the example that we can use longitude and latitude with this syntax in order to subset the field only in this, for example, with longitude between 10 and 15 and latitude between 35 and 40. So we have redefined, for example, the get item and so the square brackets in order to subset the field. We kept cell and iCell from xarray, that are the two methods provided by xarray. What we have added is these methods that allow you to subset, for example, by bounding box. And the field can be anything. It can be a grid, can be a profile, can be points, and the CRS can be also a rotated pole or a geodetic. The B box is just defined, and it will take into account all this stuff and will create a field that is subsetted by the bounding box. There is also a method for just getting points. So for example, you have a field that is defined on a grid, and you would like to have only some data that are related to some points defined by latitude and longitude in this case. So what this will create is a new field, but this will be a points field because it will have just points that are the nearest point by definition of the method. You can also use nuts in order to select, for example, just part related to the nuts level. So you can use the nuts code. We have here, so what it will return let's say, the minimal bounding box around the nuts, and then it will mask the value that are not in the nuts. In case you need just the data for example, an administrative region, you can use these nuts, and all the data outside of the boundary will be none, so will be masked. And this could be useful for doing operation and then also for visualization and so on. We have added also some methods for interpolation, and we use SciPy interpolate in order to provide also interpolations. And you can use also the abstraction of domain in order to provide a new domain where to interpolate the field, and also regridding. This is based on XCSMF. So we have integrated XCSMF, that is a library for xarray that use regridding, and use ESMF for regridding. And this is integrated also in Geocube in order to do regridding on some target domain with different methods that are available, like the nearest, conservative, or bilinear, and page. And finally, the field provides a plot method. As you can see here, we can, for example, subset by nuts and then plot. And you see here only the plotting related to the nuts region are displayed, because we have, as I said, we mask all the values around outside of the boundary of the nuts. Okay, the other data structure is called the dataset. So what we have done here is we have extended, let's say, the dataset data structure of xarray in such a way that you can represent not only a group of fields like in the dataset, but is a collection of groups. So what I mean here is that, for example, you can have a dataset that have different parameters that are not really coordinates in the dataset, but this can be used as index in order, for example, to index a particular experiment. For example, that is defined by a certain version, certain resolution, or scenario, like in this example. So let's say we have a folder with different experiments according to these different parameters. So what we have done is to extend the concept of datasets in such a way that what at the end we build is a data frame where each index is, so where each parameter correspond to a column in the data frame, as you can see now in this slide as an example. So to each row correspond a certain group of fields, of Geocube fields. So as you can see here, for example, I can have the group 0 with just temperature and precipitation. These are a group of fields that, and then in the case of the fourth row, I have another group. Maybe I have another field that has been added in the latest version. And maybe this variable was not available in previous version. So this is pretty, let's say, you can use in different ways, and is pretty flexible. And also for the dataset, we have defined a methods that allow us to apply all the methods Geocube, the Geocube field methods to a dataset. And in particular, we have this filter method that allow us to just, let's say, filter the dataset, for example, to work on particular group of fields. Like you can see here, for example, filter simulation equals CMCC will just filter what the group of fields that are related to this parameter simulation with value CMCC. Okay. I think, yeah, I'm going now just to finish the presentation. So what we are going to do in the future is adding new operators to the workflows, because at the moment, as I said, we have only just resemble and average. We will add interpolation and gridding, so this should be available as operator in the workflows and in the WPS. We are also implementing other OGC interfaces, for example, the WMS, in order to provide directly images that can be integrated, for example, now in GIS software tools. And also we have, at the moment, we also have added as a format, the GeoJSON format. So the idea also is to provide an OGC WFS interface that will allow also user to deal with, for example, GeoJSON formats and not only NetCDF formats. This should simplify, for example, also development of downstream applications. And also we are working on extending the API for publishing, updating the dataset, and also for some real-time IoT data. And also we already have some works, but this also will be, I think we'll open also some toolkits that we have developed that can be integrated with the DDS in order, for example, to prepare dataset for training and validation of machine learning algorithms. So I think this is all by me.
Okay, thank you, Marco. For now,
there are time.
Yes, perfectly. For now, there are a couple of questions, so I invite the participant to write their question or curiosity or comment. One came, I think, at the very beginning of the webinar, is about is from Ethiopia, and Charlie, I'm sorry if the pronunciation is not good, asked, would you have a means to address such type of capacity building for Africa, Ethiopia? This is connected also with one of my curiosity, Marco. Do you expect to prepare also training material, e-material to help people to use this system?
Yes, this is one of the things that we have to do we have to do especially in the next months, because we have developed a lot of stuff, but is not documented. So we need to prepare documentation and also training material in order for people, to use easily also the system. And this is something that is in plan, because otherwise it will be very hard, also to use this. For the moment, we have just documentation for the API client, but is not enough. So we can also build examples, notebooks. We have also internally already a lot of notebooks, and also with the recent advances, for example, adding this workflow, we can also show some examples of how to use also multiple datasets to do some analysis also.
Also, maybe the video that you thought could be useful, no?
Yeah. This also, we've produced this video recently. I think we can, and we will put this also in the web portal.
Okay, another question is from Firza Riani, asking, does NATS work only for administrative borders within Italy? Can we use it to subset work data to country borders, for example? Maybe I can also answer, because NATS is for Europe, right, Marco? NATS layer is for Europe.
Yeah, that's so. I mean, the example was for Italy, but we use the NATS shapefile from that are defined at a different resolution, and we use some library in order to compute then this multi-polygon, and then we just do the subsetting and the masking. So, but for Europe, the example was for Italy.
But for example, for territories outside Europe, there is another dataset that I know, that is the GADM. The name is the Global Administrative Area, that maybe could be in any case used instead of NATS for maybe, it allows to borders the administrative areas are country, county, region, province level, so for different levels within a country. So maybe they are shapefile, if I remember well.
The main point is, so what we have done, we have implemented the method for multi-polygon, and so you can define not only a bounding box, but just a multi-polygon. So then the NATS comes from having these shape files, and then we convert to multi-polygons, then we call this method, and then we can subset, and then we mask the data outside of the border, for example, the boundary.
Okay, now
I think we can extend it to if we have the shape files. We can.
There are two questions from Marco Mistri. One is about the advantage of DDS with respect to Copernicus Climate Data Store. And another question, another comment is that the current number of data sets in DDS seem limited, and especially for Italy and Europe. Any plans to expand to other global data sets like reanalysis, CMCC, and so on? So two questions in one.
So the main aim of the DDS is to publish a CMCC dataset. That's our main aim. Is clearly we were inspired by the CDS, and both for the API, even if we are changing now. So the main aim is that one. So we would like to publish through the DDS the dataset that are produced by CMCC. The SMIP6 produced by CMCC are available through the Climate for Impact portal, because we have integrated the WPS within that. But we can also expose to the WPS directly, can be exposed. So these are related to the SMIP6. But our main aim is just to deal with the CMCC dataset. We don't want to replace or just duplicate data. We have some data from the CDS that we mirror it, because we use it. And so this is something that allows us to optimize. For example, ERA5 is used in different services for different projects. So instead of every researcher to download data from the CDS and using within our supercomputing center facility, what we provide is just a sort of mirrors of this data in such a way that clearly not all the data, but just the data that are needed, for example. So we use it as a way of optimize the download and the storage also space, because that's, but we are not going to compete or to replace some services. So it's just for CMCC, this one. But we are going to open source the technology. So if someone else would like to use it for disseminating data and so on, or analyzing data, we are going to open source in the next months.
Okay, just repeat for colleagues from Ethiopia that had some connection problem, that Marco mentioned that some e-training material will be shared soon. So there will be the possibility to learn about this system. Another question is from Tiziana De Filippo, asking which kind of metadata schema do you apply? For example, metadata site schema, do you have tools to compile the metadata?
Okay, so at this moment, we just let's say, we have developed some metadata. So we have a schema that is our own. But we are now using some, let's say, standard metadata schema from, for example, the catalog. We are looking both to the DATS schema, the web, let's say W3C, and the OGC. So what we will add in this is also something that we are developing now. Endpoints, so you can have the RDF or XML according to this kind of schema. So the dataset can be harvested and included in, for example, in the European or the Italian portals for finding or searching this kind of dataset. So this is something, yeah, that we are working on it, and we should release soon also. Yeah.
Okay, then Elisa Calò asks, can we arrive at the sub-NUTS 3 area through the coordinates? Sub-NUTS 3 for Italy, for example, are municipalities, because the NUTS 3 level is provinces, our provinces. So I can say that there is another sub-level of NUTS that is the local administrative units, still providing shapefiles. So maybe she's asking if there are not NUTS arriving at the municipality level. In any case, there is possibility to do analysis also using coordinates, maybe.
As I said, if you have a shapefile, so we provide this method NUTS, we just use these NUTS that are provided, no? And but if you have shapefiles, we have a method that allows you to use the shapefile to subset. And so you can do that. So the only thing that is needed are just shapefile. Then we use Shapely to convert to multi-polygon, and then we have methods for subsetting multi-polygon. I hope this clear.
So this is valid also not for administrative area, like for example.
This is valid for anything. So if you have shapefiles, yes. If you have shapefile, then we have implemented this NUTS just because these shapefiles are available. So we have integrated. Now we have just to improve in order to download. This is something that we are doing only when needed, for example. But yes, every time you have a shapefile, you can just build multi-polygons, and then you use that in order with this method, and then we'll just mask data outside of the boundary of the different polygons that you can have defined by the shapefile.
Then another question is from Stefano Querina from ODS. How far is the DDS from a data lake concept? Could you please add a comment on this?
Okay, so in this moment, as I said, we use this intake library that allow us to define a dataset with a driver. So if we think that we can have drivers for different kind of backend storage, different files, and so on. So for example, we can define a driver for a database, a SQL database. We can define for a PostGIS, or we can define for a, I don't know, a real-time IoT. So that's the idea. So what we are trying to do also is to build a catalog, can be any data sources. So in this sense, can be defined, it can be somehow very close to could be a data lake where we can have different kind of data and different. Now, the only point is that is our data model. As I said, our idea is to have this data model where we can represent different type of geoscience data. So it could be observation, could be satellite data, could be time series, a profile, and so on. And that's something also unstructured data. But at the moment, yes, we deal mainly with grid data. But in our concept, this is something that we would like, to push in the future. I don't know if this is because we can deal with different backend storage, with different formats, and also with different types at this point of data. That's somehow can be considered very close to a sort of data lake.
Okay, there is a last question. No, another, yes, no, just a last question coming from Tiziana De Filippis. The data set have the DOI?
Yes, for each data set that is created by CMCC researcher, we create a DOI. So it's this is available for each data set produced by CMCC.
Okay, for now there are no questions, but thank you for you, Marco. And in any case, if there are additional comments or questions that you want to provide, you can write.
By the
of
way,
course. Yes.
No, sorry. Before just sorry, 1 second. No, clearly, that if I don't know if some people are not still users. So these are can you see my screen?
Yes.
Yeah, okay, the DDS web page is dds.cmcc.it. So we have also a mail where you can write, and we give support if there are issues, because usually there are some issues, no? It's not perfect, the system. And also here you can find the link for the client, for the API. No, because I forgot to say,
Yes, so for any curiosity or additional question, you can write. And I want to thank you for attending. Thank you, Marco, for your presentation. That was very clear, also for not expert people, I can say.
Okay, thank you.
So, okay, I think that we can close the webinar, and have a nice day. Thank you again.
Okay.
Bye-bye.
Thank you all. Okay, bye-bye.